So that was a nice little review, and now I want to get into some of the specifics of measurement issues in the field of psychology. And I can't sort of stress this enough that measurement is really the whole foundation of the science. If we can't measure effectively, accurately, these things that we're interested in, then we're not really doing science at all. So it really is worthwhile to think about how these ideas, these conceptual variables are being measured. And a good place to start in that is just to understand the different scales of measurement psychologists use and what they mean and when they are good to use and when they are bad to use. So again, with these operational definitions, we are, finding a way to put a number to a behavior that would obviously not have a number. And the way we generate that number has consequences for the kinds of analyses we can do and the kinds of things we're able to say, the kinds of conclusions that we're able to draw. And so that's why we need to be aware of these scales of measurement. Okay, so the first kind of variable we're going to talk about are categorical variables or nominal variables. Sometimes you'll see them called. And these are operational definitions of variables where the number you're going to put to it represents a level of a different category. So you see a bunch of examples there where this might be the case. And let's just focus on political orientation. So I am a researcher interested in how political orientation affects charitable giving, and so I need to know my participants' political affiliation. The easiest way to get that information is simply to ask them. And so I might have options. I might say, you are a Republican, you are a Democrat, you are an independent, or you're not registered. The interesting thing about those words or those checkboxes is we actually can't do analyses in these programs on words, right? We can't do anything with Republican, but you can do them with numbers. And so what researchers will do will just associate a number with each category. So you'll go 1 equals Republican, 2 equals Democrat, 3 equals independent, and 4 equals not registered. And those numbers simply represent placeholders for the categories. Now, importantly, with these kinds of scales, with these categorical variables, those numbers really don't mean anything. So if you got an average, let's say, of all the political orientations, you would get like a 2.75, and you would have no idea what that means because there is nothing that is a 2.75. So when you're using these categorical variables, the thing you really want to use them for is simply frequency counts and percentages. So how much of my sample was Republican, how much of my sample was Democrats, how much of my sample was independent, for example. So you really don't do many interesting statistical analyses on these. They're really, because they're placeholders, just used to represent a group in a statistical spreadsheet so that you can ultimately make frequency claims or percentage claims as they relate to your variable. The second kind of measurement or scale of measurement are so-called ordinal variables. Again, this is a quantitative variable, so these are numbers, but now instead of the numbers representing a category like they did with the nominal ones or the categorical ones, now the numbers represent a ranked order. So the one I think about is places in a race, right? You get first, you get second, you get third, and what the number tells you is the order in which you finished. And it tells you, who's the fastest, who's the second fastest, who's the third fastest, whatever. The important point as it pertains to potential analyses is that what's unique about ordinal variables is that the amount of difference between the first and second on a list, or the second and the third, or the third and the fourth, do not have to be the same. In fact, they are likely going to be uneven. So let's say there is a race and the first runner, finishes the 5K in 20 minutes, okay? The second runner finishes it in 22 minutes, and the third runner finishes it in 22 minutes and 5 seconds. The 2-minute difference between first and second is significant, but the difference between second and third is very small. It's 5 seconds. If you're going to put an ordinal variable, if you're going to make something an ordinal variable, you want to make sure that the only thing that is important is the relative order in which they are. If you're interested in how much of a difference exists between 1 and 2, or 2 and 3, and 3 and 4, then this really isn't for you. So again, ordinal variables simply represent an order of things, but the important thing to remember is that you cannot make direct comparisons between first and second, second and third, third and fourth, first and fourth, because the interval between them is irregular and not equal. This limitation leads us to our third scale of measurement, which are so-called interval variables. So again, these are quantitative variables. These all are. That simply just means numerical, where the interval between numbers is equal. So the difference between 1 and 2 is the same as the difference between 2 and 3. And, very important, there is not a true zero. So you might be asking yourself, okay, what does a true zero mean? A true zero means that there is an absence of something. It doesn't exist. So a score of 0 means the thing is not there. So if you would, for instance, height has a true 0, because if you are 0 inches tall, you do not exist. You're not present. You're not a thing. Okay, everything has some level of height, whether it's even a millimeter tall. So if it's a 0, it means you're not there. With interval variables, that's not true, meaning 0 on the measurement represents a very low score, most likely, but not the absence of it. So if you take the Fahrenheit scale, okay, of temperature, we know that 0 degrees Fahrenheit is very, 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 very cold. But 0 does not mean there's no temperature. There is temperature still. The temperature is very, very, very cold, right? And that's what we mean by an interval variable. What's nice, though, about interval variables is the difference between the numbers is equal, and therefore you can make comparisons between a 1 and a 2, a 2 and a 3, a 3 and a 4, and you can say things like, twice as much, or 3 times as less. You can do that kind of analyses because the intervals are equal. You'll see this a lot in psychology in Likert scales. So on surveys, you'll get people asking questions about how much you agree with the following statement that housing prices are too steep for first-time home buyers. How much do you agree with that? And you're given a scale of 1 to 7, where 1 means strongly disagree and 7 means strongly agree. People rate their scale. I'm a 3, I'm a 4, I'm a 6, I'm a whatever. But the nice thing about that is when you make comparisons between different kinds of people who fill that out, maybe from different parts of the country, you can say things like, people from rural areas were, 2 times less likely to endorse this item as people from urban areas, stuff like that. IQ scores the same way. You can get an IQ score of 0. That doesn't mean you have no intelligence. It means you have very low intelligence, and that's all it means. So the differences between the scores of a IQ score of 100 and 110 are the same because it's an interval scale, and so you can make decisions. You can say this person's IQ is twice as strong or twice as high as this person's. Again, you can do that with interval variables because the ratio or the interval between the numbers is the same, but we couldn't do that with ordinal simply because it wasn't the same. And then the last kind of scale of measurement are so-called ratio variables, which are just like interval variables, except that the key difference is there is a true 0, right? So with interval, there was no true 0, but with ratio, there are. So all the same ideas, that the difference between 0 and 1 is the same as difference between 1 and 2 and 2 and 3, and so on and so on. But here, 0 does mean the absence of something. So if something weighs 0 pounds and 0 ounces and no grams, nothing, then they don't exist. In physics, physicists use the Kelvin temperature scale, where 0 Kelvin means the absence of temperature. It doesn't exist. accuracy, whether that would be on a test question, on a test, for example. If you get a 0, it means you did not get it. It is wrong. There's not partially right. It was the absence of being correct. So anything like that, where 0 means the absence of the thing you're looking at, that's what a ratio variable is going to be. So again, just to sort of summarize these, there's 4 different scales of measurement. These are very important to understand. You will get plenty of questions about this on the exam, so you want to make sure not only you know it and know the differences between the two, but you could recognize them in sort of a real life scenario.